Hi guys, let's solve the following analytical problem together. So it says in the Cartesian plane, ABC form the vertices of a triangle. So ABC here form the vertices of a triangle. And then they say point S is the midpoint of BC. So for the line segment BC, S is the midpoint. And the line AS is perpendicular to BC. So this line AS and BC are perpendicular. The first question says determine the coordinates of point S. So seeing that S is the midpoint, we need to apply the midpoint formula. So seeing that S is the midpoint of BC, we need to apply the midpoint formula. So we can say the midpoint of BC, which is equals to S, is equals to XC plus XB over 2 YC plus YB over 2. So we can just substitute. So XC is 1 plus XB minus 7 over 2, and YC is minus 7 plus 1 over 2. So this is equals to minus 6 over 2. Minus 7 plus 1 is minus 6 over 2. So this is negative 3, negative 3. The next question says determine the gradient of line AC. So we need to apply the gradient formula. So they want us to find the gradient of this line segment AC. So notation is important. Small letter gradient AC is equals to change in y, which is YC minus YA, XC minus XA. So we can just substitute XC, YC is minus 7 minus 5, and XC is 1 minus 5. So minus 7 minus 5 is minus 12, and 1 minus 5 is negative 4. So this is equals to positive 3. So 3 is a positive gradient, and we can see the line is a positive slope. So this is the correct answer. The next question says determine the distance of BC. So they want us to find the distance BC here, so we need to apply the distance formula. So BC is equals to the square root of XC minus XB squared plus YC minus YB squared. So we can just substitute. XC is 1 minus 7 the whole squared plus YC minus 7 minus 1 the whole squared. So this is equals to 1 plus 7 is 8. So it's 8 squared plus negative 8 squared. So this is equals to the square root of 64 plus 64, and this is equals to square root of 128. But 128 can be viewed as 64 times 2. So this here is 8 square root of 2. So the last question says determine the area of triangle ABC. So they want us to find the area of this whole triangle ABC. So we can use the formula for calculating the area. So we can say the area of triangle ABC is equals to half times the base times the perpendicular height. So the base of the triangle is given by BC. We can just call this the base, and then the height of the triangle, or the perpendicular height, is this distance here, because it's perpendicular to the base. You should never make the mistake of using the slanted height. You don't use this, you always use the perpendicular height. So I'm just going to rewrite the formula in terms of the vertices used. So it's half times the base is distance BC times the perpendicular height, which is AS. So we've already found BC to be 8 square root of 2, so we can substitute it. Half times 8 square root of 2. So all that we need to find is AS. So AS is this distance here. We've got the coordinates of S, we've got the coordinates of A, so we can apply the distance formula once again. So we can say AS is equals to square root of XS minus XA squared plus YS minus YA squared. This is equals to, take the square root, XS is minus 3 minus XA is 5 squared plus YS is minus 3 minus 5 squared. So this is equals to square root of minus 8 squared plus minus 3 minus 5 is minus 8 squared. So this is equals to square root of 64 plus 64, which is equals to the square root of 128, which is equals to 8 square root of 2. So I got the coordinates for point S. We got them earlier on here. So now we can substitute AS is 8 root 2. So this is equals to half times 8 times 8 is 64. Root 2 times root 2 is 2, and 2 and 2 cancels. So the answer is 64 squared units. Thanks for watching.